let's take a look at adding and subtracting polynomials for this lesson. There are a few things that we need to remember. First, terms are separated by addition and subtraction signs. Remember that. Multiplication sort of glues things together into a single term, but addition and subtraction actually separates them into separate terms. The next thing I want you to know is that the number of terms determines the name of a polynomial. A polynomial means it has multiple terms. An example would be a binomial, something that had two terms. For example, x plus 3 would be a binomial. A trinomial would have three terms. For example, x squared plus x plus 3 would be a trinomial. Now, third thing we need to remember is that the largest combined exponents in a single term determine what we call the degree of the polynomial. If we looked at the trinomial, x squared plus x plus 3, we would say we have a term that has x squared. The degree is going to be 2. It's going to be a trinomial to the second degree. If, for example, we had y, x squared, plus x plus 3, which is really not a trinomial you're probably going to see, we would combine, though, the exponents that are in this first term, y to the power of 1, x to the power of 2. We have really a degree of 3 because there are three exponents that are combined in that first term. Okay, so next, let's take a look at example number 1. When we are adding polynomials or subtracting them, what we're really doing is combining like terms. Now, these are the same term, 9x minus 20x. They're like terms because the variables are exactly the same. So what I really have to do is do the math with the coefficients in front. In other words, I say 9 minus 20. And probably should have circled that minus because it's a negative 20. How do I do that? Well, I really subtract 9 from 20, and I come up with the number 11. And I say 11 what? Well, it's really 11x. Is it a positive or a negative? It's a negative 11x because my negative 20x would have been the larger term. And when I say larger, I'm talking absolute value. Remember, if we have a negative and a positive, we subtract them and we keep the sign of the larger one. Let's look at example 2. First, we have to ask ourselves, are they like terms? Well, yes, they are, because both of them have the variable that are identical. X squared is the variable. So all I have to do is math with the coefficient in front. I'm going to say 14 plus 9 gives me 23 x squares. Example number 3 has three different terms. This would be a trinomial, three terms, and I'm going to say two of the terms are alike. Let's put a block around the two that are alike. There's one, it's an x squared term, and the second one is a negative 3x squared. So I've got 15x squared minus 3x squared. I'm only going to combine those first by subtracting. I'll say 15 minus 3 gives me 12x squared. And then the third term is a minus x. It's not like the others, so I can't combine it with anything. I just bring it down. Number 4. Well, first let's take a look and see how many terms we count in number 4. Here's 1, 6a squared. Here's 2, negative 4ab. Number 3 is a positive 7b squared. 4 would be just a squared. 5, or negative a squared. 5 is going to be negative 5ab, and 6 is going to be a 9b squared. So really it looks like I've got 6 terms to consider. What I want to do is find matching terms. Let's start off with the first one, 6a squared. Look for other terms that have the same variable, a squared. Well, here's one, and when you put a block around it, remember to include the sign that is in front of the term. The sign that's in front of the term stays with it. And do I have any more a squared terms? That looks like it. So I'm going to say 6a squared minus a squared. And if there's no coefficient, the coefficient is a 1. So it's really like saying 6 minus 1 or 5a squared. I've taken care of those. Let's look for another term. How about these ab's? I'll put circles around these. I've got a negative 4ab. And I've got a negative 5ab. Well, when I combine those, I really add them and keep the sign. It's going to be a negative 9ab. And now you will notice that the sign becomes the operation separating the terms. Last, I'm just going to underline these. They're both b squared terms. A positive 7b squared, a positive 9b squared. I'll add those together, and I'll have 16b squared. Now my terms are no longer alike. They've all been simplified. They've all been combined. And so my answer is a trinomial. And it's a trinomial to the second degree because the highest exponents are just 2. The middle term even has exponent of a to the power of 1, b to the power of 1, so all of them are really to the power of 2. So it's a second degree trinomial. Take a look at example number 5. There's something we have to do with example number 5 before we can do anything else. They've got it grouped for us. They've got 2x plus 5 in parentheses, but there's nothing I can do with 2x plus 5. I can't combine them. They're not like terms. Then they've got a minus sign outside parentheses, and that should send up a red flag to you. You should understand that that minus has to be distributed to each term that is inside the parentheses. In other words, it's sort of like multiplying a -1 times each of the terms. So I'm just going to write down my first two terms, 2x plus 5, because they don't change. Then I'm going to distribute the -1. -1 times 3x would be a -3x. And the -1 times a -9 is going to give me a +9. Now I have the terms that have to be combined here. Which ones are alike? Well, I have x's. 2x minus 3x. That gives me a -1x. And remember, when I have 1 for a coefficient, I don't really have to write that. The number in front of the variable is the coefficient. It doesn't have to be written if it's a 1. So I'll just put the negative sign out there. That's important. And then I have a +5 and a +9. Well, I add 5 plus 9 is going to give me 14. +14, the operation is now the sign, the sign is now the operation that separates my two terms. So my answer is -x plus 14. Let's see if we can do the same thing with example 6. This would be a good one for you to try on your own. Look and notice that the first trinomial doesn't have any like terms, and the second trinomial has a negative that has to be distributed. So try that first and then see how well you did. Well, first I'm just going to write down my first trinomial, x squared plus 2x plus 1. Then I distribute the negative, or -1 if you want to. You can say I multiplied everything times a -1. And a negative times 3x squared would be a -3x squared. -1 times -6x would be a +6x. And -1 times a +2 is going to give me a -2. Now find like terms. I'll start with the highest exponent, 2x squared minus 3x squared. Well, this is a +1x squared, so it's like saying 1 minus 3, or a -2x squared. I'll subtract and keep the sign of the larger one. The next one is going to be my x squared terms. Let's put a circle around those, and remember the sign stays with the term that it's in front of. 2x plus 6x, 8x. And finally, the last one is +1 minus 2. Well, we'll subtract those again, and we get a 1 negative because the 2 is definitely bigger than the 1, and it was a negative. So my answer, -2x squared plus 8x minus 1. And you get to do the same thing for example 7. The first one, I'm going to look at the first polynomial, which has 4 terms. And they're not alike. None of them are alike. I can't combine anything inside parentheses, so I'll just write them down. Now, I need to distribute the negative throughout the parentheses. See if you can do this, and then start your tape back. So I multiply -1 times each of the terms. -1 times 3u to the 5th is going to give me a -3 u to the 5th. Remember, the sign then became the separating operation, didn't it? -1 times a +6u squared gives me a -6u squared. -1 times a -8u gives me a +8u. And -1 times 2 is a -2. In essence, multiplying everything by -1 just changes the sign of everything inside parentheses, doesn't it? Now let's see if we can find like terms. I'm going to start with 5u to the 5th, and I'm looking for u to the 5th terms. I see one, -3u to the 5th. 5 minus 3 would be 2u to the 5th. The next one I see, the next highest exponent, is this one, -4u squared. I have another u squared term, -6u squared. When I combine those, I really add and keep the sign. Negative 4 minus 6 is negative 10u squared. And then I have, see if I can put these in a triangle or a weird shaped box so it's different. I have a positive 3u and I have a positive 8u. Well, I can add those together. 8 plus 3 gives me 11u. And then the final one, negative 7 minus 2, well, I add those and I keep the sign. I have a polynomial that is 4 terms. The highest exponent that I've got is the 5, so it would be a 4-term polynomial to the 5th degree is what this one would be. All right, number 8 is your last example. Let's take a look at number 8. Inside parentheses, my first trinomial, nothing can be simplified because they are not like terms. Let's just take those and write them down. And let's look, it has a plus. It's adding the other two that are inside the binomial that are negative 3x squared plus 5. Well, this time I don't have to distribute a negative. So it's really the same thing. I'm just going to write down minus 3x squared plus 5. The signs don't change if it's a plus outside parentheses. So now that I have it all written down together, I'm looking for terms that are alike. There's 2. The x squares, 7x squared minus 3x squared is 4x squared. And then I look to see, do I have any terms that have just plain old x? We'll only have one. So it doesn't have to be added to anything. It just brings down. I just bring it down. And then I'm looking for numbers. Well, I have a negative 9 and a positive 5. So I'll subtract those and keep the sign of the larger. And my answer, 4x squared plus 2x minus 4.